So yesterday we talked about finding the area between two curves, right? The idea that we had was, okay, we got this curve, and we have this curve down here. To find the area between them, what do? We took the integral of each function and then subtracted, but it's always which one has to go first? The upper function has to go first, because if the lower function goes first, what kind of answer are you going to get? Negative. Now, think about it. If the integral of f of x, so let's say this bottom one is f of x, is 2, and the integral of g of x, I forgot my dx here, is 5, the upper one's 5. If I subtract these, if I subtract f minus g, I'm going to get what? Negative 3. If I subtract g minus f, I'm going to get 3. So it's the same numeric value, but it's just a different sign. But one thing the AP readers do not want to see as far as work is this. The integral of f of x minus g of x dx from a to b, whatever that is equal to negative 3. Right? And then they go, oh, and you go, oh, it's not supposed to be negative, it's got to be positive, so you go 3. And that's it. Now, technically, you are right, but that's not going to cut it, because they're going to want a justification or something that says, why did it go from negative 3 to 3 all of a sudden? Now, we do know that when I subtract them, right, when we do subtract them, we're going to get the same numeric value. So if you put an absolute value around it, that might be considered okay. But what's best? You always do the upper function minus the lower function. Always. Okay? No questions, no doubts about it. Now today, though, we're going to extend this a little bit, and we're going to look at a function that looks maybe like this. Okay, we'll call this f. And we're going to look at another function that maybe does this. And we'll call this g. If I want so this is g, this is f. If I want the area between the two curves, the area bounded by the two curves, what am I talking about? I'm talking about both of the areas put together, because both of those regions were bounded by the curve. You get what I'm saying? So what's wrong with that then?
Oh, because neither one is the upper.
You see, yeah, there you go. It changes. What changes? The upper function changes along the way, right? So it will not be good enough to say, okay, the integral from a to c of f of x minus g of x dx. Now, obviously, that might be an issue. You go, well, what if it's negative? I'll just put an absolute value around it and call it good. In a way, that's okay, except for if I'm taking the integral from a to c of f minus g, this part's going to produce what? That'll give me a positive because f is above there, right? But this side will give me a negative. When I put them together, I'm not going to get the total area. I'm going to get what? The net area, and I don't want that when I'm talking about area. Okay? So let's get going here. All right, rules of integration. This will help you. Remember this rule? The integral from a to b of f of x plus g of x is what?
Limit from a to b of f of x plus
Not the limit, but the integral. The integral from a to b of f of x dx plus the integral from a to b of g of x dx, right? What about this rule? The integral from a to b of f of x dx plus the integral from b to c of f of x dx. Yeah. So the integral from a to c of f of x dx. What has to be the case for that rule to work? The upper bound of one has to be the same as the lower bound of the other, and same integrand, right? Whereas here, the integrands were different, but what's the same? The limits are the same. This second rule is going to help us with what we're talking about today. Okay? We're going to have to separate these functions into two separate pieces here. So let's take a look at just the basic one here. Y equals rad x plus 2 and y equals x cubed. And it's bounded by the x-axis as well. Do you guys know what rad x plus 2 looks like?
Like this. Oh, no, like this higher.
Rad x plus 2 is this. Sorry, rad x is this. Rad x plus 2 is a shift back, right? Because think about it, what number do you have to plug in to get back to the root function? -2 gets you back to the root. So the graph of rad x plus 2 is a shift back 2. Now what is the graph of x cubed?
The squiggles of...
Right? Where does it cross the x-axis? In this case, it crosses at 0, so it looks something like this. Now, if I'm saying I want the region bounded by those two curves and the x-axis, remember, it's got to be bound, it's got to be enclosed. So what piece am I looking for? That one. That's very good. That's very good. We're looking for this thing right here, right? So, yes, this function dives down here, but then there's no enclosure. So it's bounded by the curve, it's bounded by the curve, and it's bounded by the x-axis. If it wasn't bounded by the x-axis, there's no answer here. So we're looking for the area of the yellow piece. Okay. What do we notice is happening as let's say we put our finger on the x-axis at the left and move this way? What is taking place as we move along? What concern? Okay. If I start here and I start moving this way, what area of concern might I have?
Oh, 0.
At 0, well, how am I going to find this area, just this part right here?
Integral from whatever that point is to...
From whatever this is to this of what?
Y, the first one.
Of just rad x plus 2. Because this region, was this region in the quadrant 2 bounded by x to the third at all? No, except for the 0, 0, right? So the area of this is just the integral of rad x plus 2 dx from what to what?
-2 to 0.
From -2 to 0. Now what about this region here?
The integral from rad x plus 2 minus the integral of x.
Okay, so this part is what we learned about yesterday. We have an upper function and a lower function, right? So that would be the integral of rad x plus 2 minus x cubed dx from 0 to what? Wherever they intersect, right? Now, this was not from yesterday. This is just the area under the curve. So we don't have the combination of the two functions because this region wasn't bounded by the two functions. You guys okay with that? Okay. So generally, let's just call that A, B, and C. What would the equation say? So the integral from A to B of rad x plus 2 is just this region. This region is the integral from B to C of rad x plus 2 minus x cubed. Okay? Now, we can't combine those. Why not? Because, well, yeah, the upper bound and the lower bound match, but the integrands are not the same. Okay? This is from yesterday. So if I'm looking at just this region from B to C, right, you have an upper function and a lower function. So it's the upper function minus the lower function. Okay? Now we're not going to solve this one, but that's just the setup. Is there any more questions? Please ask before I go on. Yeah. Right. Now, we could maybe argue that this rad x plus 2 comes back around this way, right? But then it's not a function. We're actually going to get into that more later. Then you would have to do something weird. But we'll talk about that later. All right, are we good with this? All right, let's do an example and see how you do. What is the area bounded by x squared and 2 minus x and the x-axis? So I'm going to give you a minute to graph this on your paper without your calculator. You should know how to do this. So we have x squared, we have 2 minus x. Now, let me zoom out here. X squared looks like this, right? And 2 minus x looks like this. Okay, so these are going to intersect up here, and they're going to intersect there. That's true. But if I shade in this region, that is the region that's bounded by x squared and x and 2 minus x. Is it bounded by the x-axis? No, I don't want that then. I want the thing bounded by 3 things. So I'm looking for this piece.
Wait, Mr. Bunyan. Wait,
That's a good question.
So what if, can you extend like the linear function a little further to the left?
Way over here?
Yeah.
Okay.
And then draw a line down from that and it's bounded by the x-axis.
Yeah, but it's also bounded by the line that you just drew.
But
And that wasn't indicated.
if they're on,
Exactly. So that means there's no boundary over there, so you can't find the area. Okay, so back to Taylor's question. What would the upper function be? Do you have a function that sits on top of the other function? No. This is dealing with something new. It's not going to be upper function minus lower function. It is, we have something going on here and something different going on here. Does that make sense? So where is the area of concern? Where is the piece that is changing things? Where they intersect. We're looking right there is where things change. Now, if I look back this way from the origin to that point, how would I find that area there?
make it a rectangle and subtract the...
Okay. First, let's find the point of intersection. What's the point of intersection?
X squared equals 1.
You're going to set them equal. Okay, sometime or another I'm going to set them equal. So x squared equals 0.
No.
That's giving me, okay, that's giving me my lower bound over here, right? Okay. So it's not really a point of intersection. So x equals 0 is one concern. The other concern is the actual point of intersection. So that's when x squared equals 2 minus x. How do we solve that? Get everything on one side and factor. So you get x plus 2 times x minus 1. By the way, those aren't the answers. Those are the factors. What are the intersections then? Negative 2 and 1. But negative 2, we talked about, we're not looking at that part. We can cross that out. And then the other point of concern is where the line hits the x-axis. Oh, okay. So these are actually points of intersection because we're talking about where does the parabola hit the x-axis, right? So that's why we set the parabola equal to 0 because the x-axis is when y equals 0. And then we're going to set the line equal to 0 to find that intersection. So that's when x equals 2. So now we're going to break it into pieces. We know that this point is 1 because that's where they intersected. The x value is 1. So how am I going to find the region, the area of this region?
Make it a
Rectangle.
rectangle.
Take the integral
From 0 to 1.
from 0 to 1 of what?
X squared.
Of just x squared. Because the line has nothing to do with that region. And how am I going to find the area of this region? The integral from 1 to 2 of the line. Because the parabola has nothing to do with that. So in this case, we're not subtracting a function minus function because you don't have one function that's above the other one. Okay? So it's just the integral from 0 to 1 of x squared plus the integral from 1 to 2 of 2 minus x. Okay. And then I'm not going to dwell too long on this. How do you evaluate that? Antiderivative. So 1/3 x cubed from 0 to 1, and then 2x minus 1/2 x squared from 1 to 2. Plug in and subtract. And then solve. So 5/6. And that kind of makes sense. When you graphed it, it was a pretty small piece, right? Yeah? Are we okay with this?
Yeah.
One person?
Wait, why did we get rid of the negative 2 and the x?
If we look at the scope of the whole parabola and the whole line, so that's line. Parabola is this. This is where they intersect here.
Oh, but we don't care about the point here.
Right, because we're looking for here. So that has nothing to do with it. Now, if I was looking... So, side note, what if I was looking for the region bounded by the line in the parabola? What would the equation be? The integral? Negative 2 to 1. Hey, focus, please. Of the upper function, which is 2 minus x, minus x squared. Okay. And then dx. So that's if I want the region bounded by just the two curves. But if I want the region bounded by the two curves and the x-axis, that's a different region.
If it didn't say x-axis, then it would have
Right. Yeah, that would have been based on yesterday. Does that help? A little bit? The difference between the two? All right, let's see what we get here. What is the area of the region bounded by negative x cubed plus 6x and negative x squared? Yes. While you do this problem.
Wait, for real? Is there a quiz on? No,
How do you, yeah, there's a quiz coming up. How do you solve, how do you graph negative x cubed plus 6x? No. It's going to be a negative. It's descending basically overall. So it's going down and then 2 bumps, right? Where does it cross the x-axis? Factor and solve, right? All right, do that.
Can you help us? I know 1 0.
So we know what x squared looks like, right? Negative x squared. So that's the downward parabola. That's the negative x cubed plus 6x. How did I know that? If I set it equal to 0 and find the 0, so I'm going to factor. So you got x. I'm actually going to factor negative x. So what do you get? X squared minus 6, right? And then from here we have to factor this. Okay, you can write, yeah, okay. You can write it as x has to equal what? X has to equal 0, or x squared has to equal 6. Because if x squared equals 6, this would give me 0 here. You guys okay with that? So x then is plus or minus rad 6. You guys okay with that? So that means those are my zeros. So negative rad 6, 0, positive rad 6, and since it's a negative, we can do something like this. You're looking for the region that's specifically bounded by the 2 curves. How many points of intersection do they have? Remember end behavior? Which function, the x cubed or the x squared, is going to eventually get below? X cubed will be below x squared eventually, right? Okay, so what region am I looking for? Am I looking for this region? Why not? That's bounded by the x-axis. Looking for this region and that region. All right, figure it out. What were our points of intersection? 3, 0, and negative 2. Okay, so again, we do have 2 regions. So we're looking for the first region. The first region, what is the upper function? Negative x squared. So we can see that the blue curve is above the red curve here. But in this region, the red curve is above the blue curve. So that means, that indicates that we need to separate our integrals. So we're going to find our points of intersection by setting them equal to each other. What did I do? I got everything to be positive, or at least the first term to be positive. Factor, what does it factor out to? X times x squared minus x minus 6, and then that continues to factor. So your intersections are 0, 3, and negative 2. So what's the first integral? What's the first equation? The integral from negative 2 to 0. Okay. You guys, you're trying to do too many steps at once, maybe. Negative x squared is the upper function, minus negative x cubed plus 6x. Make sure you do that, please. dx from what to what? Negative 2 to 0. So that gives you the first region. Now what do I have to do? Plus the integral from 0 to, was it 2? Oh, 3. Of, what's the upper function now? Plus 6x minus negative x squared. Okay? So that's the setup. Now solve. No calculator. Come on, these are polynomials. You should be able to figure this out. Oh, maybe, wow.
Yeah, I don't know if you can get that. Maybe you can use a calculator.
Well, you could get it if you wanted to, but, you know. Is that right? Oh, because the antiderivatives. I know, I'm looking at that going, okay, those are all going to give me whole numbers. But I made the same mistake you guys make. You forgot to take your antiderivative, right? What's the antiderivative? Negative 1/3 x cubed. This one's going to be plus, so it'll be plus 1/4 x to the 4th minus 3x squared. Good. This one, negative 1/4 x to the 4th plus 6. No, I'm sorry. Plus 3. See, I took the derivative there. Plus 3x squared plus 1/3 x cubed. Right? And then evaluate from there. Are we good with that? F of x is sine of x, and g of x is negative cosine of x, cosine of pi x. I want you to find the area of the blue region. So notice it's not just about points of intersection, because where does the blue region end? At x equals 1.5. The other thing is, on your test, when you take the antiderivative of sine pi of x, a lot of you guys did that wrong. Say that one more time? Yeah, it's part of the question. That's why I put a 1.5 there. All right. In order to find the points of intersection, it's going to be sine of pi x equals negative cosine of pi x. Any ideas on how to find x? Just plug in values, see what works.
Why did you divide it?
Tangent of what? So you ask yourself this question. You can take the arc tangent, that's fine, but... All right, I could take the arc tangent, but just think, when does tangent give you negative 1? Is that right? Tangent, let's see. Tangent's negative when, in this domain, right? 7 pi over 4? That's true, but it's also 3 pi over 4. It's going to be in this quadrant, right? And that quadrant. Because cosine is negative and sine is positive. So the question is, yeah, which one do I want? You're right. Oh, we're not done yet either. That means pi over x equals... True, but equals, when does tangent equal negative 1? 3 pi over 4 and 7 pi over 4. Now, how do I solve for x? Divide by pi, so x equals 3/4 and 7/4. But I'm only looking for the point that's between what and what? 0 and 1.5. So that means that one's gone. So that's your points of intersection. Say it again. No, because 1.5 isn't... You're assuming they're symmetrical. If I said 1.6 and just made the graph look like they were symmetrical, you're over-assuming something you can't over-assume. Yeah, sorry. You're assuming they're the same. Don't do that. You're right. Now that you know the point of intersection is 0.75, then you can do that. But if you didn't know that it was 0.75, you can't do that. And you can't, and backwards, you can't say, okay, this is obviously right in the middle. You don't know that. What if that was 1.6? Then you would have said that's 0.8. But that's not right. All right, let's take a look at the answer here. The setup, somewhere, where is it? Okay, the points of intersection, like we talked about here, we're going to set them equal to each other. Sine of pi x equals negative cosine of pi x. Then we divide by cosine, and as a result, we end up with pi x equals 3 pi over 4. So x equals 3 over 4. And then what's the first equation? Yeah, it's plus because it's minus the negative, right? Okay? And then plus the integral from 3 over 4 to 3 over 2, because 3 over 2 is 1.5, of now the blue function minus the red function, so g minus f. And I'm not going to put you through that torture. Granted, I'm not going to put you through that torture, but like I said, on the test, you had something that looks like this. If I'm looking for the integral of, what would the first one be? Sine of pi x plus cosine of pi x, right? Okay. I'll just look at the first piece. We're looking from 0 to 3/4. You could use u substitution. What would be a good u? Pi x, and that's fine. What is the antiderivative of sine? Negative cosine. Now it's going to be negative cosine of pi x. But again, if you take your derivative, you're going to get sine of pi x times pi. So how do I get rid of that times pi? 1 over pi. You guys okay with that? What's the antiderivative of cosine? Sine of pi x. And then we'll have a 1 over pi out front. And so all of that will be evaluated from 0 to 3/4. That's just the first region.